With the advent of multi-storied buildings and large-span bridges, the dispersion of load to the soil through foundation has become a very important aspect of civil construction. It is needed to be handled carefully for better economy and durability of structure. Foundation is that part of a structure which is in direct contact with the soil and transmits load to it. Foundations are categorized as shallow or deep. A foundation whose depth is smaller than its width is termed as shallow foundation. In a deep foundation, on the other hand, the depth is greater than its width. Pile foundations belong to the category of deep foundation. Pile foundations are generally used if the bearing capacity of the soil is low or the subsoil water table is close to the natural ground level. To know the bearing capacity of soil, appropriate investigations should be done in the laboratory. A pile is a long vertical member of timber, concrete, or steel which can be driven or bored into the ground for transmitting the load to the soil. The load can be transferred through friction piles, end bearing piles, or friction cum end bearing piles. The use of pile foundation in modern times has become necessary due to heavy loads transmitted by structures to the soil. The different types of piles available are timber, concrete, and steel. In concrete piles, we have bored and driven piles. Bored piles can be cased or uncased, and uncased piles can be normal or under-reamed piles. In this film, we shall be discussing the construction procedures involved for bored, uncased, cast in situ piles. The basic equipment required for this purpose is the boring rig. The rig is equipped with a bucket at the base to bore the hole and to dredge out the excavated material. The bucket is attached with a telescopic galley which helps in the vertical movement of the bucket in the borehole. A rotary unit is provided near the middle of the telescopic galley to give clockwise and anti-clockwise movement to the bucket. The verticality of the borehole is observed with the help of the indicator scale fixed on the telescopic galley. The telescopic galley can also be tilted depending upon the inclination of the borehole to be dug. The whole operation is controlled by the operator from the cabin equipped with controls. The reinforcement cage for the cast in situ pile is fabricated in the fabrication premises and brought to site on trailers. The concrete, which is to be used for casting, is made in the mix plant under strict quality control and brought to the site in transit mixtures. Now, let us understand the construction procedures involved in boring the hole for the pile. For this, the center of the borehole where the pile is to be cast is first marked on the ground with the help of two reference points. The bucket is then lowered at this central point and boring started by giving clockwise movement to the bucket with the help of the cable. The bucket is then pulled out of the hole, giving anti-clockwise movement, and the excavated material discharged at certain distance away from the pile location. In this manner, the entire digging process is completed. The excavated material is then loaded in tippers with the help of a hoe and taken away to be dumped in low-lying areas. The depth of the excavated borehole is measured with the help of a chain. The length of the chain is then measured with the tape and compared with the required depth of the borehole. If the depth of the borehole conforms to the designed depth, water mixed with bentonite clay is pumped into the borehole so as to prevent the caving in of the sides of the borehole. The reinforcement cage, which is fabricated as per the design in the fabrication unit, is then brought to the site. It is then mechanically lifted and lowered into the borehole. If the length of the borehole exceeds 10 to 12 meters, then the reinforcement cage is made in two parts. The second part of the cage is welded to the lower part in position. Cement concrete blocks are provided on the outside of the outer reinforcement of the cage at intervals to maintain proper concrete cover. Once the reinforcement is placed in position, then the concrete is poured into the borehole through tremie pipe, which is taken down to touch the base of the borehole. The tremie pipe is made up of number of modular lengths of pipe which are screwed together to make up the required length corresponding to the depth of the pile. The hopper is then placed in position over the tremie pipe to receive the concrete from the transit mixture. The mouth of the hopper connected to the tremie pipe is blocked with a plate and the entire hopper is filled with concrete. The plate is then removed and the concrete is allowed to flow through it continuously. This is done to prevent joints in the concrete all through the pile length. After one batch has been poured, the tremie pipe is lifted up and down to allow the flow of concrete in the pipe. The bottom position of the tremie pipe should always remain embedded in the concrete in order to maintain a continuous concrete surface. After every batch of concrete is placed, the length of the tremie pipe is shortened by removing one part. This is how the concreting is completed for the cast in situ board pile. The pile is always cast some length above the desired level and cut at a later stage to bring the pile to the desired level of the pile cap. This is done because the concreting in the top portion of the pile may get disturbed, which otherwise would reduce its load carrying capacity. Over the group of piles, the pile cap is then cast. Here we can see the reinforcement being placed for the pile cap. The columns are cast over the pile cap with proper anchorage of reinforcement from piles. Pile foundation, constructed as per the design and specifications, can cater to the transmission of loads to the soil effectively and efficiently, meeting the present-day requirements of heavy loads as in the case of multi-storied buildings, bridges and other structures.